Hi, in this video we will cover the demonstration of the voice triggering and processing with cloud connection to IBM Watson Reference Design. The demonstration of the TI design consists of two C5000 platforms, the C5545 Booster Pack and the C5517 EVM. They both essentially run the same demonstration, except that the C5545 uses 2 microphones and the C5517 uses 4 microphones. The CC3220 SF Launchpad is the backend for the Wi-Fi cloud connectivity. The demonstration consists of two different setups, one that's C5517 based and the other one that's C5545 based. A linear microphone board, or LMB, that has 4 microphones in a linear array is used to capture the audio. The captured audio is sent via I2S to the C5517 or the 45 DSP. The audio is transmitted from the C5000 DSP to the CC3220 via UART. The CC3220 establishes a Wi-Fi connection and then transmits that audio clip to the IBM Watson servers for transcription. The IBM Watson servers then transcribes the audio and sends back a text string to the CC3220. In the case of the C5517 based demo, the transcribed text is shown or displayed on the CC3220 that has a Sharp OLED connected to it. In the case of the C5545 based demo, the transcribed text is sent back via UART from the CC3220 to the C5000, where the Booster Pack OLED shows the transcribed audio. The demo can only handle 4.5 seconds of audio at a time. So the way it works is that you would say the trigger phrase, which is "Hello Blue Genie" in this case, and then any subsequent audio for 4.5 seconds is recorded and sent to IBM for transcription. Please note that this video does not cover the IBM Watson Cloud account setup. The instructions on how to do this are provided in the TI design guide, so follow along the instructions there to get set up. Let's first take a look at the C5517 based demonstration. Let's start by connecting the linear microphone board to the C5517 EVM. Please follow along the TI design for the wire mapping. Let's now get the CC3220 Launchpad ready for connection. A couple of jumper wires would need to be connected to the headers on the underside of the Launchpad. Connect the Sharp OLED to the top side of the CC3220 Launchpad. Please ensure the Booster Pack VCC lines up correctly with the OLED VCC. Next, let's wire up the C5517 EVM to the CC3220 Launchpad. These are the UART connections. The TI design guide has a wire mapping to connect the Launchpad to the C5517 EVM. Let's now switch gears to getting set up with Code Composer Studio CCS. In this case, the left instance of CCS is set up for the CC3220 and the right side is for the C5517. Ensure that you have the relevant CCS projects imported into the CCS project workspace as described in the TI design guide. There are two ways to run the binary on the CC3220 Launchpad. You can either use Code Composer Studio to load a .out file, or you can use UniFlash to flash the binary onto the CC3220. In this case, we will take the Code Composer Studio route to load the .out file. The UniFlash steps aren't covered in this video, but please follow along in the TI design guide on how to do that. Launch the target configurations for the CC3220 and the C5517 EVM. Connect the cores and ensure a gel file is loaded for each core. In the case of the CC3220, the UART output from the CC3220 Launchpad is also shown here. When the binary is run on the CC3220, the UART should show the status of the Launchpad. In this case, it has connected to the Wi-Fi network and ready to accept an audio clip. The console output in CCS for the C5517 environment will show the status of the demonstration. In this case, the board has initialized and is now waiting for an audio clip. Let us now test it out. Hello Blue Genie. What is your name? You will now see on the CC3220 Booster Pack console, the audio has been captured and sent to IBM Watson for transcription. In this case, we also have the transcribed text showing on the C5517 console. Hello Blue Genie. Set temperature 82 degrees. Let's now take a look at the C5545 Booster Pack based demonstration. Please keep in mind that this demonstration only uses 2 microphones out of the 4 mics on the LMB. The demonstration setup in Code Composer Studio is very similar to that of the C5517. In this case, it is assumed that the CC3220 based binary has already been flashed on the CC3220 launchpad using UniFlash. Please ensure the jumpers for JP2 and JP3 on the C5545 Booster Pack are connected correctly as shown here. Just as in the previous demo, connect some jumper wires on the underside of the CC3220 launchpad as shown here. Connect the C5545 Booster Pack on top of the CC3220 launchpad as shown here. Ensure that the VCC pins on either board line up correctly. Let's now connect the linear microphone board to the C5545 Booster Pack headers. Please follow along in the TI design guide on the wire mapping for this. Let's now test it out. Hello Blue Genie. Temperature 82 degrees. Hello Blue Genie. 75 degrees. Hello Blue Genie. Testing 1, 2, 3. Hello Blue Genie. 83 degrees. Hello Blue Genie. 79 degrees. Hello Blue Genie. 85 degrees. For more information on this demonstration, please check out these links. Thank you for watching.